It's inevitable that security logs will have gaps, either due to benign system errors or due to attackers intentionally disabling login to help cover their tracks. And of course, it's just not technically feasible to collect detailed logs about every little thing and store them forever. So, what can we do to plug the holes in our visibility left by imperfect login? Hi there, I'm Andy, and in this video we'll be exploring how to use osquery to make point-in-time assessments of key security properties without having to depend on logs. Imagine an attacker has obtained credentials for this network and is in the process of implanting malware and backdoors. With event-based login, we defenders will have visibility of the actions that are being performed at specific points in time, such as a new local user account has been created on each machine and added to the local admin group. And perhaps a new scheduled task has been created to run CryptoLocker malware to encrypt all user data in, say, 6 months' time. But if our attacker is smart, they know that these events would likely be flagged to a security analyst to investigate. So, the first step in their attack is to disable the log collection agent on each machine. Here, by stopping the WinLogBeat service. And their last step is to clear the local logs before re-enabling the log agent. We defenders now no longer see the specific backdoors and malware implanted into the system. We just see that the event log was cleared. Now, of course, clearing event logs is suspicious and should be investigated, but how can we investigate if we don't have logs? We need a slightly different mindset here. Events tell us what has changed between a starting state and an end state. For example, the starting state may be that there's only 2 direct members of the local administrator group. The event is that a new user is added to this group. The end state is that there's now 3 direct members of this local admin group. Without logging, we can't see the specific event that's happened, when and by who. But we can still observe the end state, if nothing else by logging onto a machine and manually viewing the local admin group. But this doesn't work well at scale. It's slow, time-consuming, and doesn't allow for easy comparison. This is where a tool such as osquery comes in. It, along with the Fleet graphical frontend, allows us to ask questions about the current state of machines in our estate by using a SQL-like syntax. Some data is available as saved queries, for example, listing out all of the currently configured scheduled tasks. Each time we run a query, we must specify which machines we want to run it on. I'm selecting all of the Windows machines in my lab for this one. The query then gets sent out to the osquery agent running on each machine for data to be gathered, and as each one completes the task, it reports back to Fleet. Okay, so viewing the list of scheduled tasks is one thing, but at this point we're still left with a lot of manual effort if we're hunting for signs of badness. So let's start to refine the query. Perhaps we've seen an intelligence report suggesting that an attack group of concern to us typically creates a backdoor task named bacon. So we just need to add a where clause onto this query to identify any machines which have a task where the name includes the word bacon. The documentation panel on the right side of the screen provides some useful hints as to the field names we need to specify. Here we can see that there's 2 machines that have a potentially suspiciously named task. The queries we've looked at so far have involved examining a single table, but osquery makes scores of them available to us. And, like with databases, we can do awesome things by joining tables. For example, we have a table that lists groups, and we have a table that lists users. And we have a table that maps the relationship between users and groups. So, if we wanted to list all the user IDs which were in the administrator group of any machine, we could join the tables together like this, with the following where clause. Here we can see that the same 2 machines that had the bacon backdoor service also have a little piggy user account in their local admin groups. We'll touch on a couple more examples later, but hopefully by now you're itching to give this a try yourself. And, good news, setup is pretty simple. Fleet, that graphical user interface for osquery, is provided as part of Security Onion, the Linux distro that we've been using across the other videos in this series. The only thing required on the server side is to run sollow to update the local firewall to allow local network clients to communicate with the osquery service. Each client needs the osquery agent to be installed. Security Onion provides a set of downloads for Windows, Linux and Mac clients, which are specifically built to include the necessary server config and secret keys for our particular server, all packaged up into a single installer. So, for a Windows machine, we just need to run the MSI file, wait a few moments, and job done. Logging into Fleet, we can see this Windows server is now listed in the console, along with the Security Onion sensor that Fleet is running on. Manual installation is not ideal, but a GPO can automate the rollout. We just need to create a new policy, and then define a software installation under Computer Configuration, Policies, Software Settings, specifying the path to the osquery MSI file stored on a network share. Once clients have picked up the new group policy and installed osquery, they too appear in the Fleet console. But osquery is not just for Windows. Installation on Linux is just as simple. In this case, running dpackage to install the Debian package on this Ubuntu machine, and then verifying that the service is up and running. I don't yet have any Linux automation set up for my lab environment here, so I'm going to repeat this manual install across the other Linux clients. Once complete, another refresh of Fleet shows all the devices now reporting and online. We really only scratched the surface with the example queries from earlier. The documentation pane is really useful to explore other tables available. Some that I think are particularly noteworthy are the registry table, which provides access to examine any registry value. Similarly, File allows for searching across file systems. Login Sessions shows which users are connected to a Windows machine, including distinguishing between those with local sessions, remote RDP connections, or network share sessions. Processes lists all running processes. And you can examine the command history of Linux users via the shell history table. Check out the documentation for more, and of course remember you can join tables together for extra power. Do let me know in the comments what awesome queries you've come up with. An endpoint query tool such as osquery will never be able to replace a comprehensive login solution, and nor should it. These tools serve two different purposes. But they are entirely complementary, with each one helping to address the deficiencies in the other. Typically, log events are better for real-time correlation and alerting of known bad actions, versus point-in-time queries being more useful in threat hunting or verifying compliance to technical policies. It's also worth noting that osquery has a daemon process which can run queries on a schedule, and then generate alert events if there's a change between consecutive runs. I'll probably create a video dedicated to this in the future, so get subscribed if you don't want to miss it. But that's all for now. Drop a note in the comments below if you have any questions or ideas for future videos. I'll see you next time.